here. We're just going to go through some of our backgrounds, and then kind of what Quartus does, and then some interesting projects. And hopefully through all that, you can kind of see how the backgrounds we have in our education apply to our engineering knowledge. And what's really cool about Quartus is we do a lot of different things, and so we're not like really focused. But we'll get into that in a bit. So like she said, my name is Chris Lai. I'm a project engineer. I'm in the Mechanical Aerospace Systems group. Basically, our company is divided into analysis and design, and within design there's optical systems and aerospace. I graduated from Colorado, and I focus on consumer products and aerospace, and here's a couple of stuff I did. Straddle launcher, UAV, medical device, some thermal managing system of some molten tin, and basically that's a air control surface fixture for this aircraft here. It's the little control surface called the flap, which angles the aircraft so you can land.
Chris, what is the medical?
It's a drill. It's a bone drill, actually. So for orthopedic surgery. So if you ever break your femur, you have to drill a hole through it and then shove a titanium rod. So that's kind of what. Basically, human body is like a carpentry project. You have hammers, chisels, just made out of titanium.
Yeah, so that one, it provides some positive feedback to the person using it, so they know not to blow out the back of the bone.
Yeah.
So that's where the engineering part of it comes in.
Yeah.
It's not just a Makita drill.
Yeah. Yeah. So yeah, bone is a circle, hard outer shell, soft inner, and you just want to drill through that first hard instead of punching through the other. And if you accidentally punch through, you might break a vein or something. So that this hard guides the surgeon to only penetrate that first outer shell instead of punching through.
And my name is Tim Christianson. I'm a project engineer at Quartus, and I've been working there for about 6 years now. And I work in the optical system, so I spend about maybe about half my time behind a desk doing math, researching, or paperwork, or analyzing data. Then I spend the other half in a clean room, most of the time messing with very high-powered lasers or very expensive cameras. I'll get into one of my projects that I've worked on for most of my time at Quartus a little bit later, but I wanted to spend a few minutes just kind of discussing or describing the path that I took to earn my college degree. I grew up in a very small town in Wisconsin, in a very small school, a little bit bigger than your town, but we didn't have any type of AP classes or anything like that, and but we did have all the physics and calculus, and I excelled in math and physics, and it was actually my physics teacher who suggested that I should be a mechanic or be an engineer, and I just responded with, "What's an engineer?" Neither one of my parents went to college, and I didn't have a lot of experience with higher education or any idea on how to do the college application process or anything about scholarships. So it was that kind of ignorance with the application process, and then cool movies like Predator and Rambo and that I'm going to walk into the Marine Corps recruiting office somewhere in the middle of high school. So I'll just go through my path relatively quickly. Enlisting in any type of military is very easy. They'll sign you up with no questions asked. But getting everything you can out of the service takes a little bit more research and planning. First, there's the Asvab Test. It's the Armed Services Vocational Aptitude Battery. And that's a test that determines your skill levels in math, language, and problem solving. And a higher score on your Asvab test will qualify you for more higher skill jobs and additional bonuses and benefits. And your job is your MOS, your military occupational specialty. There's acronyms everywhere in the military. And then for benefits and signing bonuses, a lot of times recruiters only have a limited number of benefits that they can hand out, and they won't always tell you what you qualify for. I received the Marine Corps College Fund, which is an additional, quite a bit of additional money on top of the standard GI Bill, only because I was looking through brochures and I found it and I said, "What's this? I qualify for it, so I want to go sign up." And I had a pretty good experience with my recruiter, but not all of them are really honest, and so make sure that students double check the information that they're getting with an independent source, and just don't believe everything they're told. Yep.
Sorry, I don't have very much experience with the armed forces. This recruiting step is where everything kind of gets decided before you enlist?
Yeah, so you can sign up before you even graduate high school. You can sign up as a junior, and then it's under kind of a contract to just leave right after high school, and that's what I did. So you go through and you do all the pre-processing, where you take the Asvab, and then you select your MOS, and then you go through all the physicals, and you have to pass some physical examinations, and then after all that, they'll do a little background check also, and then after that, then they send you down to processing and you're on a plane. I came out here to San Diego for boot camp, so it all happens, or once you sign up, it all happens pretty quickly. But if you take your time on the recruitment process and work your way through it slowly, you can identify all the benefits that you could receive, and then make sure that you get them. It's better than just walking down there, signing up, and getting on a bus the next day. But I've met some people that have done that. So then I chose electronics as my job specialty, and I ended up as an air traffic control equipment technician. And after I came here, went to boot camp, and then I went to 9 months of intense electronics school in lovely 29 Palms, California. And that's right. Luckily I was there over the winter, so it wasn't cold. So the whole time that I was in the Marines, I knew that I was going to get out after my first term and just go to college and get everything paid for. But I did have some friends who stayed in and made a career out of it, and then I also have a few friends who got out and were able to get really well-paying jobs with just the skills that we learned required in the Marines. So after I got out of the Marines, I started going to college, and I went to every community college in Southern California, and one in Mammoth also. And then I transferred into UCSD for my final 3 years of school. And during that time, I was collecting the GI Bill, and it has changed since. Now they offer full tuition for all public schools, $23,000 a year for private schools. They give you money to buy books and supplies, and then they also provide a monthly housing allowance, which I believe is around $1,500 a month for Southern California. So unlike all of my friends in college, I always had a lot of money in my pocket, which was fun. So yeah, like the last couple of years of engineering school is just very difficult, time consuming, and stressful. And I was grateful to not have to worry about money or piling up enormous amounts of debt. So I recommend that anybody to use the military as an option to go through and pay for school, and you'll definitely gain a lot of life skills going through. Also, it's not just shooting guns or playing war and all that. So you can get a lot out of it. So after I got out of the Marines, or after college, I started working. Or during college, I started working at Scripps Oceanography in the Whale Acoustic Lab, where we built instruments that would drop 1,000 or so meters underwater, and they would passively record marine mammals, like whales and dolphins. And it was a really fun job. I got to travel a lot, working on boats. And then I worked there for 2 years after college also, and then ended up getting hired at Quartus Engineering. So as for STEM skills that I find valuable in our careers in engineering, I'm hitting on it again. Also, English, writing, and communication, I think, is the most important skills. We communicate over email all the time, and I think being able to basically write a proper email, write a proper sentence, and communicate using proper English, either in person or on paper is by far the most important skill that anybody can have. And then, obviously for engineering, math and physics, being in optics, I use geometry every single day. I don't remember everything about calculus and physics, but I know where to find the equations and I know what they're supposed to do. And you can pretty much find anything on Wikipedia, so there's that too. And then as a mechanical engineer, I never thought I would be doing as much computer programming as I am. I use MATLAB, which is a math computing software, almost every day. I use it for data analysis, I use it to control cameras, control motorized stages for automated data collection, and I've even made a couple graphical user interface programs that I can deliver to a customer so that they can analyze data without requiring us to do it for them. So MATLAB is a very powerful software, and it is expensive. But there are educational versions that are much cheaper. But I understand as teachers you like the word free. So Octave is very similar to MATLAB. A lot of the language is compatible back and forth, and you can download it free on the internet. Then another skill I believe is really important for engineering is just learning how to learn. Learning how to learn things on your own. A lot of times we'll get tasked with something that nobody else in our company knows how to do, or something that just hasn't been done before. So we have to kind of determine if it's feasible, and then determine a path, and then work through the problems that will ultimately arise on our way to solution. One example I could think of for teachers would be to assign a math or a physics program or assignment in a program like MATLAB or Octave without teaching them anything about how to code or anything about the software. There's so many resources all over the internet on how to use this stuff. YouTube is a wonderful source, and anything else like that. I think it's much more valuable for the students if they figure out that they can learn something on their own and actually learn it than if somebody holds their hand the whole way. They're not really going to pay much attention. And with that, I'll move over to Chris, and he'll talk a little bit more about our company, and we'll come back to some examples.
Yeah, thanks. What Quartus is, basically, let's see, we create extraordinary value for clients by partnering with them, providing solutions that exceed expectations while creating opportunities for staff to grow intellectually and professionally. Basically, what that means is, it's kind of a broad mission statement. It's because Quartus is such a broad company. Like, we work with a lot of different softwares, like Tim mentioned, a lot of different clients. We were founded in '97 with about 115 employees, both in San Diego and in DC. So here's a little background of ourselves. So we just started with 4 friends who wanted to get away from like the business side and just wanted to do engineering. And so that happened in '97. After 5 years, we brought 20 more employees on with full-time sales. And then from there, we launched our first prototype in 2007, expanded DC in '09, and then this is what kind of Tim was mentioning, first clean room in 2011. That's one of our colleagues in the old clean room facility. We expanded again in 2013 to a off-site facility in Miramar, and we just moved into our new facility right down on Town Center Drive next to UTC last 2 years ago with a huge clean room space, and we also started doing low rate production. So this is actually one of our examples, so I'll get into what this is in a little bit.
Question?
Yeah.
What's ISO certified?
Yeah, ISO is basically a standard. It's an independent standard that says that we do processes, we document processes, and we do everything to a certain standard. So a lot of smaller companies won't have this standard. They kind of are maybe not as organized, or they don't run projects as strict. And so ISO shows that it's independently certified that everything we make is through a standard. All our manufacturing processes follow the standard. It's well documented, and just like a sort of showing that we're good engineers. We document our processes and our findings and stuff like that. Good question. A little bit of our facilities. This is our brand new one, 47,000 square feet, 1,800,000 square feet of manufacturing space, and then 6,000 of that is that clean room. So that's that class 10,000 clean room. And then our DC is also office, of course, our eastern plants as well. All right, so this is kind of like all we do in a nutshell. Like we do system design and development, analysis, testing, manufacturing, and all these different aspects. So you can see all these pictures vary through the whole gamut. So when everyone asks me like, oh, what does Quartus do? It's like, do you have time to talk? Because we range from like headphones for everything that you touch to aircraft to satellites, telescopes. This is a James Webb Space Telescope. It's basically going to replace the Hubble soon. Aerodynamic research, stress analysis, basically anything ranging from mass-produced product to a highly engineered optical system, and we do everything in between, ranging from guy in a garage with some money, Kickstarter, to well-known aerospace defense company needed help on their project.
Sorry, another question.
Yeah.
Environmental testing?
Yeah, that's like testing if you wanted to test your aircraft or a subcomponent of aircraft, so a smaller part of it, in like high humid environments with really high temperature or really low temperature, especially really important with optical systems, especially space, where the temperature fluctuations can vary depending if you're looking at the sun or in the shadow of the earth. Like you have huge ranges of temperature, humidity, stuff like that.
Radiation and stuff?
Yeah, well we don't do radiation, we do mostly environmental, so just the stuff I mentioned.
And that includes vibration also. I just went to a vibe test last week where we were shaking a little optical assembly about this big. We pulled it down to the table and it can shake it with a known vibration spectrum. And when you're watching it, it's pretty violent, so you shake it in all axes while putting accelerometers on the important components of it to see how the internal components are reacting to the external vibration stimulus. So with optics, sometimes you need to show that your optical system can, for instance, survive launching in outer space. So it's like 25 Gs of vibration, shake it back and forth. So you have to align your system, prove that it's aligned, put it on the shaker table, and just watch it get violently shaken for an hour, a couple of hours, and then take it back and prove that it's still aligned. So it's a lot of vibration in the middle.
And here's just kind of in 2015, which is a couple years back, just the spread of Quartus as a whole. Majority is photonics or optical systems, which Tim mentioned. Aeronautics is 35% of the majority, but we're also split off into like spacecraft, industry, biomedical, so that's like medical devices, entertainment, and consumer products. So entertainment's like, back in the day we did like roller coaster car design, stuff like that, or like consumer products is part of that, so they're kind of overlapping. Cool. So get into the fun stuff, project examples.
So back in 2012, a large company called Harris approached us with a technology that recently been declassified by the government and allowed for commercial use. And that technology was just a Geiger, it's called a Geiger mode Avalanche Photodiode camera. And it's a camera that operates a lot like a digital camera with a focal plane and pixels. But each individual pixel is sensitive to one single photon of light. So at first we built a prototype in the lab. It's this guy here, and basically how the LiDAR system works, we put it in an aircraft pointing down at the ground, and then we mount the camera to the backside of a telescope and then a scanning system on the front of the telescope, and then we shoot out a pulse of light using a high-powered laser beam, and we know the exact instant that it left the aircraft, and then the light will travel down to the ground, and we can fly up to 26,000 feet, so it's the plane's pretty high up there, and then the light will travel all the way to the ground and hit the ground and then scatter off of whatever it reflects off of, whether it's dirt or trees or road or anything. And then it'll scatter in all directions, and then some of those photons find their way all the way back up to the aircraft into the 10-inch aperture of the telescope, and then land on the camera focal plane array. And the very first photon of light that returns from the ground and back will hit a pixel, and then it'll trip it, and then we record like the exact time that it happened. So using the knowledge of exactly where the aircraft is in the sky at that moment, and then using the speed of light to calculate the distance traveled, and we know exactly where the scanner was pointing when the image was taken. So we can basically place that tripped pixel as an exact location somewhere on the ground. And the resolution of the camera is 7.5 centimeters or 3 inches. And 3 inches is the distance that light travels in 250 picoseconds. That's 10 to the negative 12. So it's a very, very small distance, and our camera operates at 50,000 frames per second, so it's taking 50,000 images every second, and on every image we're getting about anywhere from 80 to 100 points of a known location on the ground. So by flying over an area a couple times and scanning it a few times, you're able to put together a 3D point cloud. And when you provide additional, or when you put it through additional processing, we can reduce that 3 inches down to less than an inch of accuracy from high altitudes. So we're able to cover a lot of ground really quickly with this system. And the prototype in the top left, that's when they first came to us, and all we did was put the camera on the back or behind some hobby telescope optics that we bought, and then we made the scanner in front, and then we actually wrote the initial code to parse out the data to show the location where the light was hitting in our lab. So it was pretty exciting when we were able to first put together 3D images and actually pick out some features in our lab, like shelves and books and stuff like that. So once we were able to prove that it worked, Harris asked us to jump right ahead and build a fully capable airborne collection system. So these are the next two pictures. And we designed, built, aligned, and then delivered one system in just under a year, which is ridiculously fast for any type of an engineering project. And the picture right here this is Qualcomm Stadium. This is one of the first data sets that we collected with the first sensor. So to get images back like this was also pretty exciting. And then, so the next couple images are all with a little bit of additional post-processing to kind of clean up the point cloud a little bit. So this is just kind of a random street. You can see things, such details such as like power lines. So it can be used, these sets of data can be used for power line management. You can see the branches, the individual branches and how close they are to telephone wires. So somebody like SDG&E could collect the full data set of San Diego in a couple of hours, and then somebody behind the desk can point out exactly which trees need to be trimmed, so stuff like that. And also obviously like flood mapping or city planning or construction projects. So that's just a cool building. That's that Aqua Blue Hotel. It's kind of look cool in the 3D cloud image. Maybe we can make that. And a couple more images. So with one of the big uses is forest mapping and ground penetration or forest penetration. Since light can actually get down to the ground through the branches and the leaves, you can actually see the tops of the trees, and then you can also see the ground below it. So you can kind of map the differences in biomass as the years progress. Keep getting more data sets and identify trees.
How does cloud cover affect it?
So the frequency of light is 1064, so it does go through moisture pretty well, but we basically just don't fly when it's cloudy. You get much better images. So one of the drawbacks is you don't have to fly at night. You can collect data during the day, but the solar energy kind of degrades the data a little bit. So it's mostly they fly at night and they wait for clear skies to fly. So it is dependent on weather. But yeah, that's about it. And we have 3 of these sensors right now. We made some upgrades from the first one, and all 3 are actually working at the moment. And one of them's out in Arizona collecting a couple sets of data there, and then we have 2 of them that are getting ready to collect pretty much most of Texas. So we're just going to go back and forth and collect all the data and process it for some use.
Is that true color, or do you?
So this is, I think they changed the color a little bit. It's usually on this one at least is height mapping for the most part. It should be a different color, like different levels, but it looks like they colored in a couple streets, couple of the streets. So we don't do any of the post-processing. The only data we collect is just to make sure everything's aligned and everything's working right. Just a couple seconds of data is a couple gigabytes of data on the computer. So it's a lot to go through. So we only look at little snippets to do our job. And I guess a little insight on the alignment that has to take place to get these types of images. I did the math at one point, and it's equivalent when we point the laser to be in line with a certain single pixel on the camera. It's equivalent to holding up a 6-inch dinner plate 3 miles away, and then we align it so that the laser is on the center of that dinner plate. So it's very tedious work in the clean room. It's interesting.
What kind of training do you provide for your clients, and how long does it take for them to learn how to use this thing?
Well, they can't align it. A lot of this stuff requires precision optical equipment to know that it's aligned and to prove that it's aligned. So anytime something goes wrong with this, they have to fly back to us. We take it out of the airplane, bring it in our lab, fix it, and then give it back.
So you have sort of an ongoing relationship with the clients then?
So it's with this system, they kept on flying over surveyors' corner cubes, and it's the way it works. Those corner cubes work is light reflects back at exactly the same angle that it hit. So when our high-powered laser shined down, it focused all the energy back into the camera and was blowing up cameras. So one year we fixed 18 different cameras that blown up, and they're all at about $250,000 apiece. So that was a little expensive for the company, but I think we to fix that, we came up with a look-ahead sensor design which shines a little laser out in front of it and has a camera on that laser beam and looks for any highly reflective objects. And then if it sees something, then it immediately closes the shutter before the main camera can see anywhere that would be illuminated by the high-power laser. So since we finished that and put that in, that was the beginning of this year, we haven't had any cameras blow out since then, so it's saved a lot of money.
And one more project we have is everyone familiar with the little label on your fruit? And how annoying it is?
It's very sticky.
That's your fault.
Yes, it is our fault, which is a good thing.
Now we know who to blame.
Exactly. So why do you have that sticker on your fruit? Well, to identify what kind of fruit it is, like different apples. There's not just green and red apples, apparently. There's like Fuji, Granny Smith, etc. There's also different sizes. There's also organics. It's also a good way to track like E. coli outbreaks. You know, like, oh, this batch of apples is getting a lot of people sick. Look at the label, you can track it back to what grove, and etc. So it actually is quite important, even though they are annoying to take off. The company who makes these came to us, and since we had some optical experience, they wanted to do a print-on-demand label. So currently, before, they had to have all the same apples, the same size, put them in the line to label it with the same sticker, right? You know, if you have oranges, you have to like replace the whole line with just oranges of the same size and go forward. But if you have different labels, or the print on demand, you just put apples, and then you can have a machine that sizes it and just tells the printer, say, okay, this is large, medium, extra large, small. And you just go boom, 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 and you print on demand. So that's how we accomplish that with thermal print heads. So thermal print heads is basically, everyone's familiar with your, the inkjet or the toner. Thermal is like what your grocery receipts are. You can rub it and it makes that black line. So it just uses heat on the sticker itself to make it. So basically the requirements were able to retrofit a current warehouse, so we couldn't change any of the assembly line. We did the whole design and build in less than a year, like Tim said. That's a huge task for something that's never been done before in the industry, and then easy operation for the users, so that the people who work on the factory line are familiar with an applicator, so that's what this is called, but they need to be able to easily learn how to use this versus not something completely different. Is there internet on this?
Oh, no, unfortunately.
Okay, I was going to show a YouTube video of just a...
Is that supposed to be YouTube?
Yeah.
YouTube.com or you?
It's YouTube. It's just the shortened URL instead of like the full long, 5-page one. But yeah, that video is just going to show like how they're labeled. Basically, this turret rotates and grabs the sticker from this roll and then punches it onto the apple. In this case, the apple. So, like I said, Quartus provided a turnkey automation system and low rate production quantities. So what we're good at is low rate prototype production and require highly skilled engineers to make, which is kind of different than your cell phones. The engineers for a cell phone have made it such that someone with not that much training can do one part of it and you pass on. So here we did the full system integration that required like not that high volume, so it didn't make sense to ramp up an entire production line for these, since there's only so many fruit houses in the country. But they still needed to be produced and still had some highly technical aspects to it. We also developed the control algorithms to print the tape, to print onto the tape, and to perfectly time the tape meeting the apple. So the apple's moving on a conveyor system, so you have to like time it right at the exact moment, so it hits the top there. And I think the fruit per minute, which we call FIBMs, fruit per minute, is about like 90 to 100 fruit per minute per line, so it's whizzing pretty fast. We did the whole PCB electronic layout with FPGA. we integrated the first prototype in 4 days with no downtime. Had a nice GUI touchscreen on here, which is not shown on a different revision. We had a touchscreen on there. Quick interchange. We basically had phases of production, first unit in 3 weeks, 12 units in 6 weeks, and then the full 100 in 8 weeks later. So we ramp up first test and ramp up. Yeah. So before I get questions, I forgot to mention the first slides. We do have internships that we offer for college undergrads. Basically, the biggest thing that we kind of like look for is people with, like you said, real world experience, and even that internship too. I think, yeah, that's always exciting. And we also do recruiting, so I brought some sweet Pulsa airplanes. Feel free to come up and grab some.